What if I told you your personality, your health, your decisions can all be represented as numbers? Sounds strange, even uncomfortable. But this is exactly how artificial intelligence sees the world. And it all started with a mathematician who carved an equation into a bridge. The story of a breakthrough. In 1843, a mathematician named William Rowan Hamilton was walking across a bridge in Ireland. For years, he had been struggling with a difficult problem. Then suddenly, a flash of insight. Right there, he carved an equation into the stone. I quid equals j equals k quid equals ijk equals 1 is 1. That moment led to a powerful idea that we can describe things using numbers and directions. And this idea became one of the foundations of modern AI. Scalars versus vectors, the core idea. Let's simplify everything. There are two ways to describe something. Scalar equals just a number. Example, walk 5 kilometer. Vector equals number plus direction. Example, walk 5 kilometers northeast. That's the only difference, but this simple idea changes everything. How this relates to us. Imagine describing a person. Age equals 25, weight equals 60, fever equals yes, diabetes equals no. To a machine, this is just a list of numbers. So instead of seeing a human, AI sees a point in a space made of numbers. This is why we say, we are all just numbers, at least to machines. What can we do with vectors? Vectors can be added, subtracted, scaled, but the most important operation is the dot product. This helps measure similarity, distance, position relative to a boundary. In simple terms, it helps answer which side are you on. The perceptron, AI's basic brain. Now imagine AI trying to classify things. Healthy versus sick, yes versus no, safe versus risky. It does this by drawing a boundary. This boundary is called a hyperplane, a line in simple cases. And the tool used to find this boundary is the perceptron. How the perceptron works. The perceptron, 1. Takes input data numbers. 2. Multiplies them by weights. 3. Adds them together, dot product. 4. Makes a decision. +1, one group minus 1, another group. If it makes a mistake, it adjusts the weights and tries again. Over time, it learns how to separate the data correctly, a powerful way to see the world. Think about this. Every person equals a point. Every decision was a boundary. AI doesn't understand you like a human. It calculates where you fall. Your prediction? Just math. The limitation, the big problem. But there's a catch. Some problems cannot be solved with a single line. A famous example is the XOR problem. No matter how you draw a straight line, you cannot separate the data correctly. This limitation caused a major slowdown in AI research, known as the AI winter, the breakthrough. Later, scientists discovered something powerful. Instead of one perceptron, use many layers. This created neural networks, and with an algorithm called backpropagation, AI could finally learn complex patterns. Final message. So what did we learn? The world can be represented using numbers. Humans become vectors. Decisions become geometry. Intelligence becomes math. And AI? It's just learning how to draw the best boundary. Outrow. If you enjoyed this, follow for more deep ideas explained simply. Because once you understand the math, you start to understand the future.